Well, after such a great introduction, I can't wait to hear the speaker myself. Sometimes all these introductions can backfire. Recently, New York Magazine voted me as one of the 100 smartest people in New York City. So I thought, wow, what an honor. But in all fairness, I have to admit that Madonna also made that same list. Let me tell you a cautionary story about a physicist. Over 200 years ago, we had the great French Revolution. And one day, there were three gentlemen about to lose their head to the guillotine. There was a priest, a lawyer, and a theoretical physicist, just like me, about to lose their head to the guillotine. Well, they put the priest's head on the chopping block, and they asked him, "Do you have any last words before we slice your head off?" And he said, "Yes, yes." He said, God from above shall set me free." Well, all eyes were on the blade. They raised the blade. The blade came down, swish, and stopped right before it hit the neck of the priest. The crowd gasped. They had never seen this before. And so the mob said, "Let the priest go, because today God has spoken." And now let's see about the lawyer. Yes, the lawyer. They put the lawyer's head on the chopping block, and they asked him, "Do you have any last words?" And he said, "Yes, maybe the spirit of justice and mercy shall set me free." Well, all eyes were on the blade. They raised the blade. The blade came down, swish, and stopped right before it hit the neck of the lawyer. This time the mob went crazy, dancing in the streets of Paris. People were saying, "God has spoken, justice and mercy have spoken today." And now let's see about the physicist. Well, they put the physicist's head on the chopping block, and they asked him, "Do you have any last words?" And he said, Yeah, I got some last words. And he said, I don't know too much about God, and I know even less about the law, but I do know one thing. If you look up, you'll see that the rope is stuck on the pulley. And then the physicist said, if you remove the rope, the blade should come down real good. Big mistake. Big mistake. Well, the rope came down, the blade came down, and the poor physicist's head came down. And it just goes to show you, sometimes we physicists have to know when to keep our mouths shut. Well, we have two great theories of science today. One is the theory of the very big, relativity. That gives us black holes, superstars, novas, exploding stars, galaxies, the Big Bang. That's Einstein's theory, the theory of the very big. Then we have the theory of the very small, and that is quantum theory. That is the theory of the atom. The problem is these two great theories don't like each other. They hate each other. Every time you try to marry these two theories, the theory blows up in your face. People have tried for 50 years to try to combine these two theories and have failed. The only theory which works is string theory. Now that doesn't mean it's right. It just means it's the only game in town. It is the only theory which can unify the theory of the big with the theory of the small.
Do you hope that we'll find what it is soon?
Well, the leading theory is that atoms are made out of tiny little vibrating strings. We are the lowest octave of the vibrating string. However, the string has other octaves. The next set of vibrations is dark matter. These vibrations are called sparticles, super particles. So we think that dark matter is a sparticle. Now remember that back in the 1950s, when we first began to smash atoms, what did we find? More particles. More particles, hundreds of particles. We were drowning in particles. In fact, J. Robert Oppenheimer, the father of the atomic bomb, said, quote, "The Nobel Prize in Physics should go to the physicist who does not discover a new particle this year."
What is science? Science is based on decidable statements. If I drop my cell phone, I know it's decidable that it will fall under gravity. Science is based on statements that you can test, reproducible, decidable, falsifiable. But the question of does God exist, does the universe have a point, is undecidable. It is not part of science. It's like trying to disprove a unicorn. Let's say you want to disprove the existence of unicorns. It's really hard to do because maybe some island, maybe in outer space, there are unicorns. How do you prove that unicorns do not exist? Very difficult. Now, I'm a physicist. My goal in life is to complete Einstein's dream of an equation, perhaps no more than 1 inch long, that will summarize all physical knowledge and allow us to, quote, read the mind of God. So what was his point of view toward God? Einstein said there really are 2 types of God, and that's the source of confusion. The first God is the personal God, the God of vengeance, the God that smites the Philistines, the God that answers your prayers, the God of Moses and Isaac and Jacob. Einstein said he couldn't believe in that God, but there's a second God, the God of Spinoza, Leibniz, the God of harmony, beauty, simplicity, elegance, that the universe could not have been an accident. So I see no evidence of God. However, that doesn't mean that there is no existence, there's no meaning. That doesn't mean there's not a purpose or a God out there. I just can't see it in the equations of physics. So in string theory, which is what I do for a living, we think we have a candidate for the theory of everything, the theory that eluded Einstein. And so we even now have a candidate for the mind of God.
Do you believe in a God?
I would believe in the God of Einstein. Einstein was asked this question many times. And he said, look, there are 2 kinds of God. So let's be clear about this. The first God is the personal God. The God that answers prayers, the God of Isaac, Moses, Jacob, the God that parts the sea and walks on water. The God that answers prayers, the personal God. Einstein said that no, he believed in this other God. The God of Spinoza and Leibniz, the God of reason, the God of beauty, elegance, simplicity. That it's amazing that the laws of science are very simple, very elegant, very mathematical, and it couldn't have been an accident. He said to himself that, look, we are like children entering this huge library, this cavernous library. All we can do is take the first book, open up and read the first page of this first book of this cavernous library. And so he said that he believed in the God of order, the God of simplicity and harmony. I would say, well, yeah, maybe God is not necessary to create a Big Bang, but then who created string theory? Where did the theory come from? Where did the mathematics come from? And at that point, physicists stop. Okay? So we can go before the Big Bang. We're not embarrassed about that anymore. But then the question is, where did the law come from? Who is the lawgiver? God is supposed to be the lawgiver. If the law is string theory, where did that theory come from? And I think even Stephen Hawking would say, I don't know.
What is the difference between the strings in string theory and the most fundamental particles in the competing theories?
Well, we think that they are tiny little rubber bands that are extremely small that vibrate at different frequencies. One frequency is called the electron. You change the frequency and it becomes a neutrino. You change it again, it becomes a quark. You keep on changing it and you get all the hundreds of particles that make up the universe. So physics is nothing but the harmonies you can make on these tiny little vibrating strings. Chemistry is nothing but the melodies you can play on all these vibrating strings. The universe is a symphony of strings.
When Star Wars came out, people loved the movie, but the critics said, Death Stars? Nah, you cannot destroy a planet. A planet is too big to destroy, they said. Well, that's not true. First of all, there's no upper limit to the power of a hydrogen bomb or a laser. You can make them arbitrarily powerful to blow up an entire planet. How do I know this? I know this because when I was in high school, my mentor was Edward Teller, father of the hydrogen bomb. And he even offered me a job designing hydrogen warheads. I turned him down because I wanted to work on something even bigger than a nuclear detonation. And that was the Big Bang. So let's talk about this. Gamma ray bursters are one way to destroy an entire planet like in Star Wars. They are the largest source of energy. They're black holes, second only to the Big Bang. And unfortunately, recently, we found one pointing directly at us. This is WR104. You're staring down the gun barrel of a star that will blow up, and when it blows up, its beam is pointed at us. This is WR104. This is the Death Star. Any empire could take a dying star, point it in a certain direction, aim it, and then fire it at Alderaan. Now, to be fair, we don't know whether this star has already blown up. Maybe it's already blown up. It's 8,000 light years away. Maybe 8,000 years ago, it already blew up, and we're just too stupid to know it. Or it may be a dud. We don't know. We know very little about black holes. All we know is we are staring down the gun barrel of a potential exploding star. Now, on the internet, just last week, they did a recalibration of this. This thing may just miss the Earth. The latest evidence shows that the beam that comes out of this Death Star may just miss the Earth.
Hyperspace is dimensions beyond the visible universe. Everybody knows the universe is expanding. But then the question is, what is the universe expanding into? The universe, we think, is expanding into another dimension. We think our balloon is expanding into 11-dimensional hyperspace. Now, get your head around that. We're way beyond the fourth dimension. We think that the instant of creation was basically a quantum fluctuation in 11-dimensional hyperspace.
Why 11?
It turns out if you construct a universe of 13, 15 dimensions, the universe is mathematically unstable. The mathematics shows that these universes topple down to 11 dimensions. You can't escape it. String theory is the only theory which selects its own dimensionality. You can write Newton's laws in any dimension you want. You can write Einstein's equation in any dimension you want. But why do we exist in 3 dimensions? For the first time in history, we now have a theory which actually selects its own dimensionality, because these other dimensions are unstable. And then 11 dimensions, we think, ultimately collapses down to the 3-dimensional universe that we see and touch.
What's the 4th dimension?
Well, Einstein says the 4th dimension is time. So if you want to meet somebody in Times Square, you say, meet me on 42nd Street, 5th Avenue, 10th floor at noontime. So it takes 4 numbers to specify lunch in Manhattan. But we now believe there could be other dimensions, perhaps as many as 11 dimensions. And we hope to test these ideas with the Large Hadron Collider.
Through them, the outpost on Mars, what purpose do you think that'll serve humanity?
In the short term, nothing. It's a waste of time and money to go to Mars in the short term. But in the long term, we need an insurance policy, because I think we should become a 2-planet species. Why? Because you see, the dinosaurs did not have a space program. And that's why they're not here today. We are here today. We mammals are here today precisely because the dinosaurs did not have a space program. It's a cosmic shooting gallery out there. Meteors, comets, asteroids and stuff. They could hit the Earth and wipe out all life. So we need an insurance policy. It doesn't have to be immediate. We don't have to have a crash program, but I think we should be a two-planet species at least in order to make sure that humanity can survive the death of the Earth. Now, it's a law of physics that the Earth will die. Poets ask the question, will the Earth die in fire or ice? I know the answer. Fire. 5 billion years from now, the sun will expand and we will have the last nice day. The oceans will boil, the mountains will melt, the sky will be on fire, and we will go back into the sun. The Bible says, from dust to dust, ashes to ashes. Physicists say, from stardust we came, and stardust we will return. We are made of stardust. Every atom in this room came from the heat of a star. We will go back into the sun in 5 billion years. That's why I say, yeah, let's go to Mars.
And in 1968, string theory was found by accident. Two postdocs, Veneziano and Suzuki, were looking through a math book, and came up with the beta function, which seemed to describe the collision of pi mesons. Why should a math book describe the intricacies of the collision of subatomic particles? Years later, we found out that it was a vibrating string that made all these things possible. If you were to summarize all physical knowledge, I mean everything, the whole shooting match, lasers, microwaves, gases, liquids, everything into two great theories, they would be the theory of relativity, which gives us black holes and big bangs, the theory of the big. And then we have the theory of the small. That is atomic physics, which gives us laser beams, transistors, the internet. All the electronic wonders that we see around us are consequences of this quantum theory. The irony is, and this is the fundamental problem rocking all of physics, these two theories don't like each other. The theory of the big and the theory of the small hate each other. Every time you try to combine them, it's like a shotgun marriage. It never works. And this is where string theory comes in. String theory is the only theory in all the decades we've worked on this that actually merge these two into a single theory. It's amazing. They just like zip, form one coherent framework. Now, some people say, well, maybe I don't like string theory. Maybe I want another theory. Well, hey, there is none. This is the only game in town. No other theory has been able to combine the theory of the big, relativity, with the theory of the small, the quantum theory, into a single theory. This is the only game in town. So I tell young people, if you don't like it, create your own theory.
The space elevator. Now, this is a really cracking idea, and when we think about it down here at sea level, we think about the winds that we're buffeted by, the cyclones that come through, or the hurricanes in your neck of the woods. How does this thing work?
Well, it works like Jack and the Beanstalk. Jack climbs up this beanstalk into heaven. Why doesn't the beanstalk fall down? Because it's like a ball on a string. Why doesn't a ball on a string fall down? Because of centrifugal force. The same thing with a space elevator. It is spinning around the Earth, and centrifugal force keeps it afloat. The problem is that steel will crack. Steel is not strong enough to sustain a space elevator. However, now we have carbon nanotubes. Now we have graphene. Graphene is made out of one layer of carbon. It is the strongest substance known to science, stronger than diamonds. The strongest substance known to science is graphene. If I have a sheet of graphene, I could take an elephant, put the elephant on a pencil, and balance the pencil on a sheet of graphene, and it won't tear. So if a space elevator is made out of graphene, it'll work. So what's the catch? There's got to be a catch someplace. The catch is the world supply of graphene, pure graphene, is about this much. We need thousands of miles to create a beanstalk to heaven. So it's a technical problem. One day we will do it. Perhaps late in the century, we will go into an elevator, push the up button, and go into outer space.
That's right.